Good evening, everyone. We are Group 16, and today we are going to talk about HTTP proxy server application and implementation. So, what is this proxy server? The proxy is the intermediate between the client and the server. In the most basic example, instead of sending requests directly to the server, the client routes all the requests through the proxy. The proxy then establishes a connection to the server and forwards the client request. The proxy receives the server's response and transmits it back to the client. It is important to note that the proxy is effectively serving as both an HTTP client and a HTTP server. So, why do we have to use the proxy? Well, it has a lot of advantages like security. A proxy server reduces the possibility of a breach. Proxy servers provide an extra degree of protection between your servers and outside traffic. And the second one is balances the traffic by balancing the request to the server so that none of them are overloaded. And also, it is employed to generate a single web address that will act as the access point. It also helps in content filtering by retrieving a resource without analyzing it. There is no rule that says a proxy must only fetch and serve files. Performance: a proxy can decrease the requirement to connect to remote servers by keeping a duplicate of the pages it retrieves. Privacy: all inbound resource requests are logged by web servers. This information often compromises the client's IP address, browser, or other softwares that the clients are using, and the date, time, and the requested file. Purpose of the project was to construct a network application that uses the StreamSocket API. This program supports simple HTTP GET requests. Multiprocessing is used in the software, allowing the server to manage multiple clients at the same time. Cases for dealing with errors have been put in place. The proxy saves the web pages in its cache. The job of the server is to run in the background and serve clients who connect to it. The server in our application creates a new socket with the socket function and connects it to a local port with the bind function. It then uses the listen function to listen for incoming connections before entering an unending loop of accepting new connections with the accept function. On each new connection, fork is called, which creates a new process or a faithful replica of the server that takes over to serve the client who made the connection. As a result, a large number of clients can be served at once. It then enters a new never-ending loop in which it receives orders from the client on a regular basis via read function.
Everyone, this is Manovia. Now, I'll be giving you an overview on the project system design. We are implementing a web proxy that passes requests and data between multiple web clients and web servers concurrently. This will give you a chance to get to know one of the most popular application protocols on internet, that is Hypertext Transfer Protocol. As Manoj explained earlier, how the HTTP protocol acts as a medium to communicate between client and server, we are using this HTTP protocol as well as Python socket programming. The purpose of this project was to construct a network application that used the Streamline Socket API. This program supports simple HTTP GET requests. We also implemented multiprocessing, which is used to allow multiple clients to send requests at the same time. The job of the server is to run in the background and serve clients who connects to it. The server in our application creates a new socket with a socket and connects to a local port which is binded to it. It uses the system function to listen for incoming connections before entering into an unending loop, accepting new connections with the accept system function. On each new connection, function is called, which creates a faithful replica of the server that takes over to serve the clients who made the connection. As a result, a large number of clients can be served at the same time. It then enters to a new never-ending loop in which it receives orders from the clients on a regular basis. Coming to the implementation cycle, in this, the client sends a request to the public URL. In this case, any application request URL may be a hyperlink, that is HTTP link with both the default port. The host resolves the IP of the reverse proxy server. The reverse proxy server, which is monitoring to this address, receives the request. The reverse proxy server then examine the URL to determine whether the request must be proxied. A reverse proxy can be any part of the URL to redirect a request along with the protocol, host, port, path, or querying string. The reverse proxy server setting defines the outbound URL to transmit a message request that is normally the end server who is in charge of delivering the content. Then the reverse proxy server sends the request to the destination server. The response from the target server is then received by the reverse proxy server. So the reverse proxy server reads the request and transmits back it to the client. Now let's see how we implemented this project. We have used Python programming to do the both client-side scripting and the server-side scripting. We have also included the proxy server in the server-side scripting. We have chosen Python as it is an open source software and portable and very easy to use. So coming to the code, in the left side, you can see the client-side scripting. We created a server destination and binded a port to it. As you can see, we have binded it with port number 80. Then we have created a client socket and set up connections from server to client socket that is created. Now we initialize the convert to HTTP header to send client request via encoding the client socket with it. Finally, we have closed the socket. In the server-side scripting, we have created a proxy server and a server that receives and listens. We binded the TCP socket and created a loop to receive requests from the client. We have also included multiprocessing target function that helps in handling various client requests at the same time. In the left side, you can see the error handling function for the page if it is not in the cache. We also have the output error message for the HTTP error, that is page not found.
In this slide, you can see the receive functions in the left screenshot. And in the right screenshot, you can see all the error handling functions. We have considered the status of the socket. If the status of the socket is 301, it means it is moved permanently. Or if the status is 400, it means a bad request. Likewise, if the status is 404, that means the page is not found. So similarly, we have handled all the possible errors in receiving requests in the error handling function. So this is how we have implemented the HTTP proxy server implementation application using Python socket programming.
Coming to the configurations needed to run this proxy is basic and can be done with basic requirements. We used a Chrome web browser in a Windows operating system. You can also use it in the Linux as well, and we use the Python to implement this. And now let us proceed to the demonstration of our proxy. First, we have to locate the proxy file and copy its address, then run with a certain port number attached to it. In this example, we took 80 as our port number. Now let's open a web browser and search for any website with the port number we used before. Here apache.organization is the website we are trying to connect. And now we can see in the console that the data has been extracted from the website. And we can also see the connection requests and responses in the console. And finally, to conclude this presentation, we created a simple proxy server in Python that connects the client to the server through socket programming. Python is an open source programming language that is both cost effective and portable. While testing the proxy, we successfully connected the client request and received a response. Cases for error handling are implemented and the proxy catches and the web pages. Thank you.